Last time, I talked almost entirely about PowerPoint as a tool that can greatly enhance your lectures, but also as one that can sometimes be a little bit distracting. I'd like to follow up now by talking about other technologies, some of which are so low tech that we don't even think of them as being technologies at all, and some of them so high tech that many of us still haven't mastered them. The low-tech examples I have in mind are things like the old blackboard and its slightly more up-to-date cousins, the whiteboard and the flip chart. Both tried and true veterans of many a classroom and thousands of coaching sessions and on-the-job training seminars. And also good old show and tell, just the sheer act of bringing something to class. Many of our professors, me very much included, see a lot of continuing usefulness in technologies of this kind. Now, higher and newer technologies include things like email, clickers, web pages, podcasts, and blogs, all of which help stimulate student-teacher interaction. One of the great trends of college-level teaching over the last few years has been the move away from uninterrupted lecturing and towards as much interactivity as possible. A great deal of educational research supports the idea that interactive environments stimulate better learning and also better retention. So whether it's a low-end technology or a high-end one, these tools tend to engage students often more than PowerPoint. I'm going to talk later in the course about seminars and discussion classes, but it is worth spending a few minutes at this point talking about the uses of technology in interactive teaching. Well, older and simpler visual technologies, particularly the blackboard or whiteboard, remain useful despite recent innovations. You've only got to think about why that should be for a moment and it becomes radiantly clear. Every teacher ought to be able to use the board effectively. In some respects, it's more versatile than PowerPoint because you can't change a PowerPoint slide at short notice, whereas you can erase from the board or add something and tinker with your own effects on the board. If you make a presentation on the board, before you leave the topic, you can emphasize the major points or assumptions or conclusions by underlining or circling key words on the board. In other words, you can interact with it as you interact with the students. If you're going to do complicated diagrams, you should practice drawing them before class. After all, it's relatively easy for you to erase diagrams where you go wrong, but it's more difficult for the students if they're trying to copy them in pen. If you're doing a big diagram, let the students know this is going to be a big diagram, leave plenty of space in your notebook so you'll be able to copy it down. And watch the students as they react to what you've done on the board. How much are they copying down? And are the essential points clear? As with all these teaching approaches, it's a good idea to get someone to videotape your use of the board. Put yourself in the place of the student trying to take notes, or try to take notes off the videotape of your own lecture. How legible is your work on the board? How easy is it to follow? Is it well organized and clear? And perhaps the commonest problem of all is the constant tendency to speak to the board when you're writing on the board. You need to learn, and it's difficult to learn, to write something on the board, then turn around and then speak. Do you erase your work too quickly? There's all sorts of things to be learned with that, even though it's now an ancient technology. As with PowerPoint, in my opinion, you don't want to write unnecessary materials on the board or the flip chart. Keep to the basics. Titles and headings, the structure, the skeleton of your work. Underline or box off key statements. And try to plan ahead for when drawing on the board is going to be able to help you clarify the material. On the other hand, it's sometimes useful to use the board spontaneously. I think what happens with me is that when I'm in class, I rarely plan ahead to use the board, but sometimes I suddenly realize how appropriate it would be. And let me show you now from my environmental course, a sort of spontaneous moment when I realized that I needed to use the board. I was introducing the concept of climate change to my environmental history class. It's a very, very puzzling thing because in each case, as you look at the evidence which the scientists offered, it's very convincing. These were people who weren't dreaming it up. You know, they were looking at data sets and coming to conclusions about cooling and warming. And then they started disagreeing about what exactly it was that they were looking at. You can imagine that. If this is the average temperature, and this is the year, what you've actually got is various fluctuations Yeah? In other words, you could say that if this was the year 1700 and this is the year 2000, then over the long term you have in fact got a rising trend. Do you see that? Yeah. But of course, if the people first became interested in trends in global climate in this year, by the time it got to this year, it would be absolutely reasonable and right for them to say, global cooling. Yeah, just depending on what they set as the baselines, how long they're going to do it. That's why it's so important in things like global climate research to get the longest possible temperature data you can, stretching, if possible, all the way back to prehistoric temperatures from Greenland ice cores. Now, in that case, the usefulness of doing an impromptu diagram just came to me, and I was able to do it on the spot because the stuff was there. On the other hand, I was breaking one of my own rules and was talking while facing the board at least some of the time, as you probably noticed. Try to avoid that as much as possible, especially if you do a lot of board work. Ask your students if they can hear you well enough if you talk while you're using the board. On the whole, as I said before, it's better to first talk, then draw on the board, then turn back and talk again. But it's always a good idea to use your students as a guide to improving your delivery and your use of the board. This give and take is itself one of the ways in which use of the board can be more interactive than PowerPoint. Now, it's also good to show, for example, a mathematical proof. If you want to show it stage by stage, again, you can write a little section of it, discuss it with the class, write a little bit more, if necessary erase a line and go back to the situation as it had been previously, rather than having the whole thing pre-digested on a PowerPoint. This is an area where the board, though older, is still the best technology. If you're going to use the board extensively, you should practice in an empty classroom to make sure that what you've written moves across the board in horizontal lines. I'm sure you can all remember teachers you had whose writing, as they got towards the end of a line, would begin to slope, and then the second line would slope more, and it would become progressively more grotesque as the teacher went on. And when you're not used to it, it's also difficult to crouch down and to write well when you're near the bottom of the board. All those things are also items which need to be practiced. When you've done it, go and stand at the back of the room to see whether what you've written on the board is clear. Ask students to tell you if it's unclear. Now, of the professors I met while preparing this course, the greatest board user was definitely Professor Steve Pollock at the University of Colorado. He's a terrific board user, and he knows how to write rapidly and straight, as you'll see here.
I is current. It's the amount of charge passing by every second. So that's the definition of electric current. And I can draw you a little picture, because usually current is constrained to be living somewhere like in a wire or something. So for example, if you have a wire and maybe you've got some positive charges in there that are able to move with some velocity v, the way you would measure the current, at least in principle, is you pick some spot and you stand there and you watch how many charges flow by you each second. And so the mathematical definition of this is just going to be dq dt.
Now, you probably noticed on that clip that sometimes Steve Pollock also spoke while he was facing the board. But after doing so, he would then turn around and recapitulate what he just said to the students, so that there was no question that they'd all been able to pick up. They could see him do it and talking as he was doing it, then he said it again afterwards. That's effective. Another use I have for the board is to ask students who arrive right at the beginning of a class meeting, the ones who come in early, I ask them to draw pictures or sketch maps on the board so that there's something for them to do as we're waiting for the rest of the students to get there. Again, this is something which prevents the awkward silence. It's a wonderful kind of icebreaker for the class itself. It gives the other students something to admire or something sometimes to chuckle over. And it shows you how well or how badly students grasp something like, for example, the geography of Europe. When I'm teaching about the history of the world wars, I need to know that they know where Normandy is when we're talking about the Normandy invasions, where the Soviet Union is when we're talking about Hitler's invasion of Russia. This kind of thing also gets the students engaged in the material more. If they know they may be called on to present something visually and spontaneously, they're likely to pay more attention. And if they've once done a map of Europe on the board, which was just awful, howlingly bad, it's more likely that they'll do a better one next time and that they'll look at a map of Europe in the meantime. I showed you last time my slides about the bicycle lecture. I often ask a student at the beginning of that day to draw a bicycle on the board, or one to draw a bike and one to draw a horse, as we talk about the transition from horse transport to manufactured wheeled machines. They're nearly always terrible, but they're a good talking point when the class begins. Now, another very old technology is show and tell. Bring objects to show to your students whenever possible. Since we know from research that students tend to remember more when visual elements are added, in addition to speech and text, it's clearly a good idea to do something of this kind. Show and tell has still got plenty of vitality and life left in it. John Hale, our archaeology professor at University of Louisville, brought in a museum curator with an array of Paleo-Indian pottery. But best of all of the objects he showed to us that day was the massive grinding tooth of a prehistoric mastodon.
We've got a mastodon tooth. Some Kentucky collector in the 19th century gave this tooth to the collections at the Filson Historical Society. It may be a tooth from one of those missing mastodons. It may be the only bit we have left from one of those mastodons. It's a back tooth. The front teeth, of course, on the upper part, the maxilla, are the big tusks. If we look again at the animal, these tusks, as on an elephant, are two of the upper teeth, and then they had these huge grinding teeth. This would have been a juvenile. If Anastasia tips it toward you, you can see how sharp and crisp. That's the underside there. Let's go the other way. It's hardly worn down at all. So this is a young individual who died or was killed, and this is what they would have eaten with. They were browsers. Mammoths were grazers like cattle. Mastodons, and this is what was big around here, were browsers like deer or goats. So they're pulling down spruce branches from little trees and so on. They need big, big grinding molars in order to shred that stuff up. Here we've got our only physical link in terms of a piece of an animal to Louisville's remotest prehistoric past in terms of when people lived here, this beautiful molar of a mastodon.
Now, obviously, that's not something which can be done every time, but whenever possible, it has a galvanizing effect on the audience. At the end of that lecture in Louisville, nearly everyone in the audience, me very much included, came up for a closer look, especially at this relic of a prehistorical animal right there in the room with us. Dr. Hale also told the story of the fact that somehow the rest of the mastodon skeleton has got lost. Hard to imagine you can lose something that big. More generally, demonstrating as well as talking has obvious benefits. It illustrates abstractions with concrete examples, and it reconciles the abstruse with everyday life. Whenever you're describing a difficult principle, if you can illustrate it practically, so much the better. That's one of the staples of Steve Pollock's method for teaching physics. Look at some of these excerpts now from one of his lectures on electricity. And this is given before a class of several hundred students at Colorado. He brings in objects like a balloon and a car light and a giant wire in cross-section to give familiar examples of the principles in the science of electricity that he's describing. He moves into the heart of the room too, to be closer to some of the hundreds of students who are in there with him. And you'll see he's a wonderful actor. He mimics things like the motion of electric current with his body or the jolt that you feel from an electric shock.
The wires coming into this room look more like this. Now that's a wire. And because there's a heck of a lot of current coming into this room. And so if you had some amount of current entering this wire, it would be able to spread itself out over a larger area. You could get the same amount of current, but less current density if you spread it out over a big fat wire like this. 0.01 amps into your arm is enough to make your muscles contract and you can't let go, which is why people who work on power lines never grab the power lines like this. They'll always touch them first like this, because if it was live and they got shocked, it would contract your muscles away from it. Because if you grabbed it like this, right, you can't let go, and now you're going to get electrocuted. Anybody have any idea how much charge there is on this balloon? Just sort of order of magnitude. Have you ever thought about that? We talked about it in class. Is it a Coulomb? Not even remotely close. If it was a Coulomb, this thing would be exploding. it's probably a nanocoulomb. So 1 coulomb per second is a heck of a lot of charge running by. And if this is a nanocoulomb and I run at 1 meter per second, you can think about what that current is going to be. It's going to be a really small current. So when you carry 1 balloon around the room, it's not a whole lot of current. The current running through those light bulbs is on the order of an amp. Here's a car battery, and when I close the switch, right? This is the extraordinarily bright car lamp, and I don't need a whole lot of voltage. A car battery is only 12 volts, and that's plenty enough to get an amp or so flowing through these wires.
Well, as I'm sure you'll agree, his liveliness and his vitality and the sheer energy which he devotes to making one point after the next in that lecture is something with which even the most elaborate technologies can't compete. He's got various pieces of equipment and he brings them to life, but what really makes the presentation interesting is what he says about them. He's constantly looking for ways to make it more entertaining and more stimulating, but more important, to make it more readily understood. And he's got a sense of theatre. He likes to make the most of the occasion, imparting to the students that he's exactly where he wants to be, doing exactly what he wants to do. Do you think that when you're teaching a big class, you need to be more theatrical?
Yes, I would say it's an element of the large lecture that I subscribe to. If you're moving this way, you keep bumping into atoms, right? You're in this metal, and you take a step because you're being pushed by the electric field, and you keep bumping into things. And so it's like you're walking in molasses. I really want people to walk away from a physics class, especially one of these large introductory physics classes, feeling that they loved physics. And so that's definitely part of my shtick in the classroom. So if there's resistance, then if you push, on average, it's like a parachutist who falls at terminal velocity. Those charges are just going to move with some particular speed. I have many colleagues who are less theatrical, but for sure, the environment invites lots of lecture demos, some of them just for entertainment value.
Give us an example.
When I'm teaching electricity, we have a device, it's called a Tesla coil. It's a metal disc which reaches a million volts, and it's quite a spectacular thing. You turn it on and sparks come flying off into the room. You turn out the house lights, and that already, there's a buzz in the room, everybody's very excited. And one of the things you can do with it is set up this extremely high voltage difference in the space around it. You can hold up a dead fluorescent bulb in the air near the Tesla coil, and the bulb will light up. And so what I'll typically do is I have a little Darth Vader helmet, and I put on the Darth Vader helmet, and I hold up this now glowing fluorescent bulb, and the class erupts in laughter, and students remember this at the end of the term.
Some new technologies are proving themselves useful to teachers and have an obvious continuing relevance for all kinds of lifelong learners as well. One of the first of these is clickers, which enable teachers to create instant statistical data for analysis, particularly useful in big classes. And here's how they work. Every student comes into the room with a transmitter device which has on it a yes button and a no button, and sometimes it has A, B, C, D, E multiple choice buttons as well. The teacher asks a question, and the students answer either yes or no, or else they press one of the multiple choice buttons, depending on the nature of the question. And the data that they've given by pressing the buttons is instantly transmitted to the professor's computer and organized into a graph. It can also be put onto an overhead screen as well. Now, this means that the teacher can use clickers to test how well a class has grasped a concept. For example, if after explaining a technique for doing a certain kind of problem, the professor then sets a problem of that kind and then offers two possible answers, he can find out at once from the clickers who's been able to apply the principle right and get the question right and wrong. If nearly all of them have got them wrong, then clearly he needs to work some more on explaining the concept. That's one of the uses for clickers. Another is for questions of preference, or for questions of patterns of liking and dislike. If you wanted to vote on what song you like, or what colour, or what movie star, anything of that sort. And you can use these preferences as the basis for statistical analysis. They're great for the study of voting behaviour in political science classes because they instantly generate data sets. And obviously they're of most use when the class is bigger. We've talked quite a lot about the disadvantages of large classes. This is a case where there's an advantage to them. Again, listen to Steve Pollock because he's a great advocate of the use of clickers.
I will pose frequently throughout the lecture some sort of multiple choice question. And sometimes I will just pause the lecture, let them think privately, and then they can vote. Mostly, what I'm really interested in is Clicker as a communication facilitator. So I will then open up the room to peer instruction. And the Clicker now allows people to change their vote as they converse with their neighbors and they begin to argue the ideas. I'll either do a second vote. Sometimes I don't even bother, especially as the semester moves on. Check out this distribution. Lots of people, but not everybody. Once again, about 2/3 of the audience thinks that they're all the same. The Clicker gives me feedback. Why did you vote as you did? Yes, please. I see a histogram. I can see it privately on my own display, which is sometimes useful. I can tell the class, there's a big split in the class, so here's something for you to argue about. So I can guide them in the middle of the Clicker question. 20% of the class who is voting for either 1 or 3. So let's just walk our way through this. Once I do show the histogram to the students, now there's feedback back to them. So the students can either see, oh yes, this was a difficult question, half the class got it wrong. Or they can see, oh gosh, 90% of the class got this right, and I'm one of the ones who voted incorrectly. I guess I've got some homework to do tonight. The act of clicking is very different than what I used to do in the large lecture theater, which was to ask rhetorical questions. You know, it's sort of the same thing. But here, the student is, they press the button and now they know I voted A. And so if I now explain the answer, it's very human if you didn't press the button to sort of listen and you go, oh yeah, I knew that. Oh yeah, I knew that. And if you pressed A and that was wrong, you can't say that to yourself. So this commitment to an answer is also part of the value of those clickers.
A second technology that's had a big positive effect on education in the last few years is email. It offers teachers greater flexibility in course management than they ever had before. The benefits are obvious. At the beginning of every semester now, I gather up the names of everyone who's in my class and into one email address write all those names, so that from that time on I can simply write emails to all of them by writing a message once. It's very useful if I want to change an assignment, if I want them, for example, to read an extra chapter in a book, or if I want them to, if I want to follow up with an answer to a question that someone asked me in class that I couldn't then answer, I can email them the answer within an hour of class finishing. If, for example, I'm away on a weekday filming lectures for the teaching company, I can simply say, when I get back, we're going to have a makeup class, and I can email to that effect. Email is also particularly useful if I need to contact a subgroup of my class. If, for example, 4 or 5 students out of 20 all made the same kind of mistake on a homework assignment, I can email just that group as an explanation of the issue without involving the others for whom it was no problem. Similarly, with email, you can send out a set of questions related to a set of readings the day before the class meets, gather in the answers by email, print out the best of them, and select a few for discussion in class. That gets them thinking seriously about the work before the class actually meets. But with email, as with everything else, it is sometimes necessary to establish some ground rules. Just as I announce what rules are applying in the class, so with the email, I actually announce how many times per day I'm going to be willing to respond, and I declare the number of hours during which email is entirely off limits. Not in the sense that I won't reply, but I won't reply in those hours. I did once open my email one morning and found an email sent by the student at about 1 a.m. and an indignant follow-up email sent about 5 a.m. saying, "Why have you still not answered?" And so it's worth spending a moment, especially because so many of our students are nocturnal, it's worth spending a moment figuring out some rules so that they don't become impatient. Another possibility of increasing usefulness is podcasts. Podcasts can also extend the work of a class outside the immediate room where it's taking place. Now, our business professor, Michael Roberto, often meditates on his lectures at the end of class and their significance, and then he creates a short podcast that goes out automatically to the members of his course. Listen to him describing how that works.
I record them in my office. They're typically about 10 minutes in length, and they reflect on some of the key lessons of the week. They're not a simple regurgitation or summary of what we've done. They're an attempt to sort of truly reflect on what we've done, maybe extend parts of what we've done where we weren't able to get to it during our class discussion. I want to say a little more. This argument, right, if you believe it, you believe that somehow they need to own the network, own the way their content is portrayed. And those 10-minute podcasts I record as an MP3 file, and the students can subscribe through iTunes, and it basically automatically downloads to their iTunes library once I've posted it, and they update. And then by the end of the semester, they've got 10 or 12 of these podcasts.
The internet, which has become such a force in American life over the last decade, also has a role to play in education. Although, like PowerPoint, it can be a bit of a mixed blessing. On the one hand, it's a marvelously convenient source of information. It's much quicker and easier to get at than in the days when you had to go to the reference library and drag massive volumes of an encyclopedia off the shelf. I'm old enough to remember those days and the sensation of bringing down a lot of dust on yourself at the same time. On the other hand, with the web, there's no quality control. You probably recall the cartoon in which a dog sitting at a computer says to another dog, "On the internet, nobody knows you are a dog." Well, that's true. But some sites are so ignorant and so misinformed that you're tempted to believe that dogs did in fact write them. So you see, at its best, the web's a storehouse of valuable information. But you've got to be a sensitive interpreter of what you find there. And unfortunately, most of our students don't yet know enough to be able to interpret it skeptically and wisely. In history, for example, they're easily led astray by conspiracy theory sites. Lots of people who've got one big idea and have become a little bit obsessive about their idea try to interpret everything else in the light of that idea, and often, of course, it's wrong and a little bit mad. But students who aren't aware of that will treat those sites with more respect than they deserve. I'm going to come back to the pros and cons of using the web a few lectures from now when I'm discussing how to teach writing. But let me give a premonition of that by saying I only let students use web sites for their papers if they've got prior written approval from me first to use those particular sites. That's my way of doing some quality control. Another aspect of the web of increasing usefulness is blogging. Professor Roberto is one of the growing number of professors who use blog sites, and here again we can hear him talking about it.
I also maintain a blog that is for the general public, but I also encourage my students to go there, and that's purely voluntary. That's not anything that's, I'm going to ever test them on or like, but it's a wonderful way to continue our discussions and dialogue. Many of these companies that we discuss, they're in the news, and so if I see them in the news, I might blog about them after we've discussed them in class, and they can see how things have continued to transpire at the company.
As libraries become increasingly digitalized, it's also possible now to guide your students directly from your syllabus to an article text with a single click of the mouse. One thing I do now, and have done for the last year or two, is on the first day of classes I hand out a hard copy of the syllabus on paper, but I also attach a copy of the syllabus to an email which I send to everybody. And by dragging it onto their desktops, they can then open it and find web links direct to the text of some assigned articles. Now, so long as they're registered students on our campus, this gives them full access to full text versions which our library has subscribed to. And for older items like speeches by Henry Clay or Abraham Lincoln, I can usually find an accurate text online and again put the URL straight onto the syllabus and lead them directly to it. That again, it gives us access to far more literary materials, much of it free of charge, than was previously possible. And of course, growing libraries of old video clips, now in the public domain, are enriching classes in history and in many other disciplines too. Let me summarize now. As teachers, we need to be careful to take advantage of the best of what is new and the best of what is old. And we need to guard ourselves against assuming that if it's old, it's no longer of much use. There's still no substitute for a lively, enthusiastic individual describing, explaining, and demonstrating to his or her class, and showing every sign of enjoying it, like Steve Pollock clearly does in his lab in Colorado. There's plenty of life left in old blackboards and whiteboards and flip charts. They let you do spur-of-the-moment pictures and diagrams, and they let you work things out at a speed which most of the students will find more manageable. One of the downsides of PowerPoint is the feeling that it's already pre-digested and it's too much too quickly. Using the board also gives the students the chance to show others what they know and to teach others, sometimes in impromptu ways. How we use these tools is the same no matter what the teaching environment. But of course, now that we've got PowerPoint and email, the web, clickers, podcasts, of course it's a good idea to use them judiciously. Just don't lose sight of the questions. What does this technology add? What does this method of teaching add? How will it help my students to learn better? Would the class have been any worse if I'd used none of it? And you should try to make sure that the answer is, the class is better and here's why it's better, because I used the technology. In the next lecture, I'll discuss some of the skills that students need to get the most out of their classes.